Right, this is your Unit 5 test review. I'm going to go through just some of the problems to try to clarify things, help make sure you know what you're doing so you're ready to rock this test. Up here you'll find your word bank. I've included most of the words you will need to know. There are other review words that could turn up on the test, but this would cover most of what you need to know on your test. Obviously the most important ones are corresponding angles, alternate interior, same side interior, parallel you definitely need to know. Transversal are all new words from this unit. To help you out with those words, I'm going to quick do a drawing here. I suggest you add it to your review also. So if I have these couple lines like this, I'm just going to throw some angles on here. The first one I'm going to do is corresponding angles. So sometimes when we say corresponding angles, we'll also say cap when we're doing a proof. That's corresponding angles postulate. So let's say angle 1 right here. I'm going to put a corresponding angle to 1. Now, in order for these to be congruent corresponding angles, these lines must be parallel. So I'm going to say they're parallel. I'm going to say 1 and 2 are congruent. And because this is kind of your top left of this circle of angles, and here this is your top left of that group, they are corresponding, they're in the same position. Also, remember, if this is obtuse and this is obtuse, they're also congruent. So I would say angle 1 is congruent to angle 2, and they're corresponding angles. Okay. Second, we'll do right here this 2. We'll do 2 and 3. So now if we look at 2 and 3, this is in the peanut butter and jelly, I call it. So I'm going to kind of highlight the peanut butter and jelly right here. That's your interior. Okay, it's between the two parallel lines from 2 to 3. If you notice, if I bring my pencil from 2 to 3, I hit the transversal and I'm going across. That means these two are alternate interior angles. Notice this one's obtuse, that one's obtuse. So therefore, angle 2 is congruent to angle 3, and that would be AIA, which up here, alternate interior angles would be your AIA. Alright, so it looks like we got same side interior left. So let's do one with this 3. So if I look at the 3, I'll circle it, angle 3. I'm going to put an angle 4 right here. Angle 3 and angle 4 would be same side interior. Notice, they're in the peanut butter and jelly, but when I go from 3 to 4, I do not cross this transversal. So, and angle 3 plus angle 4 is equal to 180. In other words, they are supplementary. Notice this one is acute and this one is obtuse. When you have an acute and obtuse, they add up to 180. So that's the gist of a lot of what we've learned for this unit. So let's jump around the review. I think I'm going to leave the vocab blank because we gave you a word bank up here. Notice I said words bank. That should say word bank. Alright, let's hop around a little bit. Let's go down here to number 12. We'll do one of these. We'll do number 12. So first it asks the measure of angle 1. Now for this one, for this one I would use the Mr. Rick trick of here's my obtuse angle. This is obtuse. I know these are equal. So I know my two obtuse angles down here are equal. So, wow, if I just mark that, then it looks like angle 2 is 100 degrees. And it looks like angle 1 is also 100 degrees. Besides, these are vertical angles. Oh, sorry. The 102 are both vertical angles. That makes this 100. And because these lines are parallel, I can jump from 100, or from the 2 down to angle 1, and those are both 100 based on corresponding angles. So that's saying number 12. You go ahead and try number 13. I'm going to move on to another problem. All right. I'm going to go ahead and do one of these up here. I think I'm going to go over to number 16. Sometimes you got to move these angles around a little bit to make them either same side interior, alternate interior, or corresponding. Or again, because we tell you those lines are parallel, you can always just use the trick of the acute and obtuse angles. Now some of them are obvious. This one is obvious. This one's acute, that's obtuse. That should help, by the way, this x plus 20 is pointing there. This one not so obvious. So this one I'm going to do something a little bit different because I can't really tell. These angles look almost identical. So I'm going to move some stuff around here. I'm going to take this this 93 and I'm going to jump it down here because they're vertical. So I can put the that's 93. And now, because this angle right here, the 93 I just drew in, and this blank across the transversal are alternate interior angles, that is 93 also. Just to make sure that I did that right, and that's 93. If I go by corresponding angles, this is 93. This is kind of your bottom right. So over here, the bottom right would be right here is 93. And look at my vertical angles are equal. So do a lot of jumping around there. But the point is now I have this 93 next to the x plus 44. So I'm going to do right here, these two are on a line together. They are a linear pair right next to each other. I'm going to do 93. That's my part here. Plus this part is plus x plus 44 equals 180. And then I do my 93 plus 44 right there. And that gives me 137. So 137 plus x equals 180. Subtract the 137 from both sides. And I get x. Subtract both sides. X equals 43. That's what it asked for. So x is 43 degrees. Yep, so we'll leave 15. Number 17, if you're looking at this one, I'm okay with just set it up. It's a little bit trickier. If you look at this, now what you got to draw out on these pictures is you follow or you find your two parallel lines. So I'm going to highlight my parallel lines. There they are. And there's my other parallel line. And then I'm going to trace the transversal that matters. I got one back here, but there's nothing on that one. I'm going to trace this one across. So now if you look, we got our peanut butter and jelly here. Your interior here, the peanut butter jelly. Are those across from each other or on the same side? It looks like they're same side interior. And besides, this one's acute. And this angle down here is obtuse, so I know they're going to add up to 180. So I'm okay for this problem, if you're watching the video, for you just do an x divided by 2 plus 7x equals 180. And there's my setup. We'll work through this. Might as well. What I'm going to do first is I'm going to multiply both sides by 2 and get rid of this fraction here by multiplying by 2, so I get x plus 7x equals 180 times 2 is 360. Now I can take my x and my 7x, add them together, and I get 8x equals 360. Divide by 8, and divide by 8, and I get x equals 45 degrees. Or 45, I should say. And that would be it. Alright, let's jump around a little bit. Oh, I know you guys want me to do 19. This is when you really need to practice. I'm going to help you a little bit on it, though. If we look here, there are some things we're looking for whenever we have this kind of picture. I call this the angle game. It sounds cheesy, but I think it's fun. You just go through and you find as many angles as you can. The tricky thing on this one is you got to use your alternate interior angles. So we're going to look for alternate interior angles. I'm going to list all the things we're going to look for. Same side interior. We're going to look for corresponding. I'm going to look for a linear pair. and I'm going to look for vertical angles. I think that pretty much covers it. If I can find those things on here, I should be able to find all of my measurements. I'm usually going to start with these two. They're the easiest, the linear pair and the vertical angles. Right here, this one. So this will be a good start. If I just start right there on the picture, I see a straight line that I traced out. So from here to here adds up to 180. So the total is 180. I can do 180. I can take away the 56, find out what's left here for h. So 180 minus 50 would be 130, minus 6 more is 124. Now, this is where I'm going to help. By the way, I'm going to write 124 here. I'm not even going to worry about all of these over here yet. But the 124 here. Now, I'm going to look for either same side interior or alternate interior. Now, I like doing alternate interior better because they're equal. So if I look here, if I take this angle here, which I'm going to highlight, and this angle, or where A is, here's my transversal. Here is my parallel line. Here is my other parallel line. Those are alternate interior angles. They both touch the parallel line. So this would be 56 degrees also. So A is 56 degrees. We got H down here is 124. Notice I'm not going in any specific order. Just for the fun of it, notice right here I got an X. So if this is 56, up here must be 56 also. I'm just giving you a few here and there. Now, right here, I'm gonna highlight a second transversal. So I know we got D in the middle here, and I'll let you try to figure out that one. But I'm gonna highlight a second transversal here. So if we ignore this half of the picture totally, we just look right there. That's kind of our basic picture. If I look here, this 39 and E again. We can jump from here to here. We can jump from here to here even. I'm going to do these two just for the fun of it. This is acute on this side. This is obtuse on that side. So I know together they have to add up to 180. So I'm going to do F plus 39 equals 180. And basically, I'm just going to subtract 39 from the 180 to find out what's left over here. So 180 minus 39 gives me 141. That's 141. And I think that's where I'm going to stop on this one. Just wanted to give you a little bit of a jump on it and see how I am jumping back and forth between the lines. Alright, jumping to the next page. Now you can find this one on your homework, but this is going to be the one I think I'll do of the two. Now, both of these problems are triangle problems. So we had a triangle sum theorem, it was called. The triangle sum theorem said this angle here plus that angle there plus that angle there. The three angles of a triangle equal 180. So the three angles of a triangle equal 180. Every single triangle. So these triangles add up to 180. Now if I look over here at this problem, there's actually three triangles here. There's one here. Those three should add up to 180. There's one here. And those three should add up to 180. And there's also one big triangle. And sometimes it's good to notice the big triangle. So that will kind of help you. I will also tell you that A and B here, I think those are a linear pair. And that will help you. For 21, I would do A first. Okay, back to number 20. So if I know these all are 180, and I know it's equal angular, you see the equal? The equal means equal angular. So that means all of these angles, I'm going to mark them, are exactly the same. So if they're the same and this one's 3x, I'm pretty sure I can call this one 3x because they're the same. And then I'm pretty sure I can call this one 3x because they're the same. And then I'm going to do 3x plus 3x plus 3x equals 180. Now, if I were you, I probably wouldn't have wrote out all of these 3x's. I would just combine like terms. I want 3, 6, 9x equals 180. Divide both sides by 9. And x equals, let's see, 9 fits into 18 two times, but then we have this extra 0, so it's going to be 20. That's the answer, x equals 20.